Algebra Lesson 14, Equalities between identical formulas. So in this lesson we'll be taking a look at how we can take two people's distances or rates at how fast they're going or how much time it took them to go a certain distance, and then find out how fast they went or how much time it takes one person to catch up with the next and things like that. So we have to use the distance formula. D distance equals the rate times the time. That formula, and we will use that one beside the other with an equals between, or there's 4 different ways we can use them. Either if we have 2 equal distances, let's say 2 people are going the same distance. They both started at home, and this guy's going here. How much time did it take them to go up to here? But maybe this one starting 20 minutes less than this one, and them both ending up at the same spot depending on their rates. Then we would use the distance of the one person equals the distance of the second person, because their distances are the same. Now, if we do the next one, which is the sum, adding 2 distances together equals this. Let's say we start here, and we're going here and here. This plus this, so this guy's distance plus this guy's distance equals a certain number. Then we would use this setup. And then if we have, and there's another one, there's 4 of these. If we have this guy's distance, so we both start here. I'll just use home again. This guy's distance, he goes up to there. And this guy's distance plus 10 miles equals that guy's distance. Then you would do distance, let's use this one as 1 and this one as 2. Then I can write it like this. Distance of this person plus 10 equals the distance of this guy. Do you see how that works? Adding these 2 together equals that, so add these 2 together equals that. So, and then there's the 4th one. This one let's say both again start at home, and we have this guy, but we need this guy, and this guy is 5 times this equals that. So you would have again 1 and 2. The distance of 1 multiplied by 5 equals the distance of the second one. So we'd have to multiply the 2 together again. So all this said, one thing to just keep in mind is that you need one of these 4. It will never be different ones, so it's going to be one of these 4. So I will go over some of these with you in the new part, and you can do the rest on your own. But the ones that I don't go over with you, just in the new part, I will go over which one do we use. Which of these formula setups do we use for the distance? So hang in here with me. This could take a little bit longer than our normal algebra lessons. So in the first one, number 1, we have a small bee leaves its hive flying due east at 6 miles per hour. At the same time, a larger bee leaves flying due west at 4 miles per hour. At these rates, how long will it be until the bees are 5 miles apart? So which one do we use? Which formula? At this point, Let me just erase these. So, let me write these four on the board. D1 equals D2. D1 plus D2 equals N. And then D1 plus N equals D2. And D1 times N equals D2. So, they have it the other way around, which works too. D1 equals N multiplied by D2. Anyone works. So, for this first one, we have a small b and a large b, and adding them together equals 5. So which one do we use? We add the small b with the big B, and then we have 5. So let's start with that. D1 plus D2 equals N. Now we need to split this into the rate and the time here and the rate and the time here. So instead of 1 and 2, let's put our small and big B. So put an S here and an L here, small and large. Now R, S, and TS plus RL and TL equals, well, adding them together, how much is it? 5. So, the rate of the small b, how fast is a small b going? It is going 6, right? Yeah, it's going 6 miles an hour. 6 takes care of the RS, then put a TS behind it, because we do not know the time, that's what we're looking for. And then the rate for the large b is 4. So now put 4 TL equals 5. Now, the TL and TS. So far we've learned that you cannot add and subtract an M and an N. They just always stay separate. In this case, the only reason we have the superscripts, I think they're called superscripts, or they're called subscripts. Subscripts. Superscripts are up top, like an exponent. So subscripts. The reason why we have this S and the L here is just to keep the two separate. You can add them together because there's just T's. 6TS plus 4TL is, and now I would just probably take one or eliminate here. So 10TS equals 5. Now, what do we do after this? Divide 10, 10. TS is half an hour. The time for the small b is half an hour. And we know that they're just flying and flying and flying till they come up to 5 miles apart. So for the large b and the small b, they both have half an hour to fly. So this S really doesn't matter. So for number 1, it's asking, at these rates, at 4 and 6, how long will it take until the B's are 5 miles apart? Your answer would be half hour. Now, that's where we use this formula. I will erase this and get to number 2. So number 2, we have at 8 a.m., Tim leaves on a hike walking 4 miles per hour. 2 hours later, his sister Erica leaves on her bicycle riding 12 miles per hour to give him a message. How long did it take her to catch up with him? So what are we doing? We have 2 equal distances. So how does that one work? 2 equal distances. So this would be Tim's distance, and this would be Erica's distance. So let's write that out. distance for the one equals the distance of the second one. Now, instead of 1 and 2, again put Tim and Erica. A T and an E. Now let's split them apart like we did earlier. RT TT equals RE TE. Now the rate, Tim's rate is 4 miles per hour. And the rate, well, we don't know the time for Tim. Do we know the rate for Erica? It's 12 miles per hour on a bike. 12. Now, do we know Erica's time? Not really. But we do know something, we do know something about her time. It's the fact that she left 2 hours after Tim. So take Tim's time and subtract 2 hours. Tim's time minus 2 hours. Now here you would do distributive property. Let's do that. 4 Tim's time equals, multiply the 2, which would be 12 TT. Then 12 multiplied by -2 is -24. And now bring it and solve your equation. Bring it back and forth, which is subtract 12 here. It's a lot of t's. All right, so these two cross each other out. We have a -24 on this side, and 4 minus 12 is -8 TT. And then to finish it off, we divide. Divide by -8 on both sides. And we have Tim's time, and here it actually does matter because Erica's time was 2 hours less. Tim's time is -24 divided by -8 is 3. So Tim's time, it took Tim 3 hours to walk all that. Now, what are they asking? How long did it take Erica to catch up with Tim? What's Erica's time? Tim's time minus 2. So Erica is Tim's time minus 2, which is 1 hour. So make sure when you read the question, it's not always just, okay, it's just this bottom number. Read the question and try to figure out what they're looking for. Now, going on to the next one, number 3, I'll read the question and then I will help you figure out what type of equation we need, and then we can move on. And then you can do the rest on your own. A Canada goose and a mallard duck left to fly south one day at the same time from the same place. If the goose averaged 28 miles per hour and the duck averaged 25 miles per hour, how long was it before they were 10 miles apart? So basically, they have that good graph there for you. So, which one did I explain like that before? Are the two distances equal? Do they equal each other? No, not necessarily. Do both distances added together equal 10? No. Does one distance plus a number equal the other distance? Yes, they have that in here. The duck's distance plus 10 equals the mallard's. The goose's distance, sorry. So we would use this one for number 3. And then you can do that one on your own. If you want, you can pause it and then do that one first and then go to the next. And then I'll read number 4. Floyd and Jim begin jogging around a lake which has a circumference of 18 miles. They leave at the same time, but jog in opposite directions. With Jim averaging 2 miles per hour faster than Floyd, what were their speeds if they met again in 1.5 hours? So, what we can do here is take and do it the same way as we did number 1. Be this one. Floyd's distance plus, what was the other guy's name? Jim. Floyd's distance plus Jim's distance is 18 miles. Make sure you have the time in there as well. And then you can do the rest of the lesson on your own. If you have questions about this, feel free to ask me, because this is one of the most brain-boggling new parts of all algebra. So feel free to ask me for help if suddenly this doesn't make sense.